We are back with our zoo example, and as I mentioned, what we are going to be doing is stepping through the same setup. We're going to have our animals, a subclass of mammals, a subclass of reptiles, but this time we're going to use pointers, and that's all going to allow us to do what's called polymorphism. So I'm going to step through the changes in the classes and actually just kind of take it from the start and pretend like we didn't do any of this before and talk you through everything. This example comes from a Shazam employee that helped us out last year create this. And so here we go. So our animal class is going to be basically what we call a pure virtual class, meaning that we're never going to create types of animal. We're only going to create types of subclasses. But we want the structure from our animal class, and so we're going to create an animal class but never ever create an animal itself. First thing that we do is we're going to use an enumerated data type to differentiate the two different types of animals, mammal and reptile. And that's done inside the public access, so we can access that anywhere that we would like. We are going to have a constructor, and that constructor is going to be a name and a weight, just like we did before. And then we're going to make a base class destructor that's virtual. And here the base class destructor virtual ensures that if a class of a derived type is accessed using a pointer to the base class, when the object is destroyed, both the derived class and the base class destructors are called. And so that's what virtual in front of here does for an animal. And basically what that means then is when I create a reptile and I destroy my reptile, it's also going to destroy any animal references that I had used. Because even though I'm not going to create an animal, this class will be used, and we do have to make sure that we clean up the memory. We still have our get name, get weight, get food, and then we're going to have a virtual get info. So the virtual get info method is if the method is virtual and it's called from a pointer to an animal, the implementation used will be either the animal, mammal, or reptile. Without the word virtual, if the method is called from a pointer to animal, the implementation from animal will be used. Because we want to have the implementation for the mammal and the reptile, and that's using polymorphism. We want it to switch. If I have a mammal, I want it to use mammal. If I have a reptile, I want it to use the reptile method. We are going to make this method virtual. And what that does is basically as the program is running, it decides as it's running whether the code for mammal or whether the code for reptile should be used. And it decides that on its own. We don't have to tell it to do that. We have your setters, set name, set weight, and feed the animal. And then we're going to have a get animal type method. This get animal type method, this comment here tells us that it's a pure virtual method, and that's when you set it equal to 0. That's what the equal to 0 means. If we uncomment that code, and I've uncommented it in the code program that we're going to run, we will no longer be able to create a type of animal. So if I were to try to create a type of animal in my driver, if I go to my driver, and I try to create a type of animal inside here directly, it's not going to allow me to do that. So if I said animal, and I said my animal equals a new animal, something like that, and I might not have the syntax entirely correct. This is going to be my pet, and right now it weighs 7, just like Slither. It should not run, and it's going to start to holler at me, and it says by using pointers to animal for the new mammal reptile. So it's giving me that error message. And so it says down below here, if you see, it says way down at the bottom, objects of an abstract class animal is not allowed. So it's not allowing me to create an animal directly. We'll come back to that, and I'll explain how we would actually do that in a few moments. If we go back to finish up talking, so if I were to put a comment statement in there, I would then be able to create a type of animal. But because we want to just use the base class as a virtual class, I'm not going to do that. So we don't want to, and this kind of explains it here. A pure virtual method is a logical choice because it doesn't make sense for the animal class itself to have an animal type. we want to enforce either inheriting and using a mammal or a reptile. Last but not least, we have some protected variables, and that is name, weight, and food. So these are your instance fields, and all of these others are your methods. It's kind of switched around from what we've done in class, but that's the way that this particular programmer did this. So all of the methods he did first. So these are all the methods for our class, and then these are the instance fields. Please note the instance fields are named with an underscore, and that's pretty typical to name your instance fields for a class with an underscore. So last comment down here that he had put in for us is, when you use virtual keyword does not allow a member of the derived class with the same name as the one in the base class to be called from a pointer. And more precisely, when the type of the pointer is a pointer to that base class, it's pointing to an object of the derived class, which means it's going to point to a reptile or it's going to point to a mammal rather than pointing to an animal. So that was a little bit of a rough explanation, but it'll get better as we go along, I hope, here. And we will continue, and I'm going to step through each of the header files, and then we'll step through the .cpp files as well. But I want to keep these videos short to start with, and so we'll just take this one little step at a time.